Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Dr. Muhammad Roslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia Profesor Engineer Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan. Yang berbahagia Profesor Engineer Teknologis Dr. Kamariah Noordin yang akan menyampaikan syarahan inaugural pada pagi ini. Pegawai-pegawai kanan Universiti Putra Malaysia, ahli pengurusan fakulti, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar, dan para penonton yang dikasihi sekalian. Selamat datang diucapkan kepada semua yang menonton syarahan inaugural oleh yang berbahagia Profesor Engineer Teknologis Dr. Kamariah Noordin. Untuk makluman semua, syarahan inaugural ini diadakan secara dalam talian mengikut norma baharu dan dipancarkan secara langsung melalui Facebook UPM dan Facebook Fakulti Kejuruteraan UPM. Para penonton dialu-alukan untuk menekan butang like dan share halaman-halaman Facebook tersebut. Mohon kerjasama untuk mengisi kehadiran yang pautannya dikongsikan melalui ruangan komen di Facebook untuk sijil penyertaan dan mata latihan CPD bagi pekerja UPM. Seterusnya, bagi memohon keberkatan syarahan inaugural kita pada pagi ini, majlis mempersilakan Encik Salihuddin bin Zainal dari Jabatan Kejuruteraan Sistem Komputer dan Komunikasi Fakulti Kejuruteraan Universiti Putra Malaysia untuk memimpin bacaan doa.
Assalamualaikum warahmatullahi wabarakatuh. Al-Fatihah. Auzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Arrahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan yu'afi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika wa azimi sultanik. Allahumma salli wa sallim ala sayidina Muhammad salatan tunjina biha min jami'il ahwali wal afat wa taqdi lana biha jami'il hajat wa tutahhiruna biha min jami'is sayyi'at wa tarfa'una biha indaka 'ala darajat wa tuballighuna biha aqsal ghayati min jami'il khairati fil hayati wa ba'dal mamat wa ala alihi wa sahbihi ajma'in. Ya Allah, Al-Wajid, Ar-Rahman, Ar-Rahim, Asy-Syakur. Sesungguhnya kami memanjatkan kesyukuran di atas segala nikmat dan rahmat yang telah Engkau kurniakan kepada kami, kedua ibu bapa kami, ahli keluarga kami, sahabat handai kami, guru-guru kami, serta seluruh warga Universiti Putra Malaysia. Ya Allah, Al-Mu'is, Kau berikanlah kami kekusyukan di syarahan inaugural yang berbahagia Profesor Engineer Teknologis Dr. Kamariah Noordin pada hari ini, supaya kami tergolong dalam kumpulan yang Kau muliakan, serta Kau muliakan juga semua yang terlibat dalam menjayakan majlis ini, Ya Allah. Ya Allah, Al-Fatah, Al-Wadud. Kami memohon kepadamu, Ya Allah, supaya syarahan inaugural ini Kau berikan kelancaran, dimudahkan dan di akhirnya beroleh kejayaan. Ya Allah, Al-Basit, Kau buka luaskanlah pintu-pintu ilmu-Mu supaya dapat kami manfaatkan dalam ibadah pekerjaan kami, sebagai sebahagian usaha kami meningkatkan kecemerlangan diri serta Universiti Putra Malaysia dengan kuasa-Mu Al-Khaliq. Ya Allah, Al-Muqid, Kau bukakanlah jalan kejayaan serta kekuatan kepada kami dan generasi-generasi selepas kami untuk kami memartabatkan serta mencintai ilmu-Mu, Ya Allah. Ya Allah, Al-Qudus, Kau sucikanlah serta Kau peliharalah hati-hati kami sepanjang ibadah pekerjaan kami di Universiti Putra Malaysia dan hidup seharian kami bersama keluarga, sahabat handai dan guru-guru kami, serta kami menjadi hamba yang Engkau redai. Ya Zal Jalali wal Ikram, tambahkanlah kepada kami kecintaan kepada segala kebaikan. Jadikanlah kami, guru-guru kami dan pemimpin-pemimpin kami terus berkhidmat dengan istiqamah untuk menabur bakti, membangunkan umat, masyarakat, bangsa dan agama. Ya Allah, ya Tuhan kami, jadikanlah negara kami sebuah negara yang mendapat limpahan rahmat dan nikmat. Kekalkanlah keamanan dan kemakmuran sepanjang zaman. Rabbana zalamna anfusana wa lam taghfir lana wa tarhamna lanakunanna khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa alihi wasahbihi ajmain. Walhamdulillahi rabbil alamin.
Majlis merakamkan ucapan terima kasih di atas bacaan doa itu tadi. Para penonton yang dihormati sekalian, seterusnya majlis dengan segala hormatnya mempersilakan Yang Berbahagia Profesor Dr. Muhammad Roslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia untuk mempengerusikan syarahan inaugural ini. Dan seterusnya menjemput Yang Berbahagia Profesor Engineer Teknologis Dr. Kamariah Noordin untuk menyampaikan syarahan inaugural beliau. Majlis dengan segala hormatnya mempersilakan.
Terima kasih saudara pengacara majlis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Teknologis Dr. Kamariah Noordin yang akan menyampaikan syarahan beliau pada pagi ini. Pegawai-pegawai kanan Universiti Putra Malaysia, ahli pengurusan fakulti, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar, sidang penonton yang saya kasihi sekalian. Alhamdulillah, syukur kepada Allah kerana dengan limpah kurnianya, kita masih lagi diberi peluang untuk bersama-sama bagi meneruskan usaha memartabatkan kesarjanaan ilmu pada pagi ini. Izinkan saya untuk membaca latar belakang Profesor Insinyur Teknologis Dr. Kamariah Noordin di dalam majlis yang gemilang ini. Yang berbahagia Profesor Insinyur Teknologis Dr. Kamariah Noordin telah berkhidmat di Universiti Putra Malaysia sejak 1988. Bermula sebagai tutor dan seterusnya dilantik sebagai profesor pada tahun 2011. Selama lebih 30 tahun berkhidmat, beliau telah menunjukkan prestasi yang baik bukan sahaja sebagai pensyarah tetapi juga sebagai pentadbir. Selama lebih dari separuh dari tempoh perkhidmatan, beliau telah diberi tugas penting seperti Ketua Jabatan pada tahun 2000 hingga 2002, Timbalan Dekan Akademik Fakulti Kejuruteraan 2006 hingga 2008, Timbalan Pengarah dan Pengarah Bahagian Perancangan Korporat atau singkatannya BPK daripada 2008 hingga 2015, Pengarah Pejabat Strategi singkatannya KOSKOM dari 2016 hingga 2018 dan seterusnya Dekan Fakulti Kejuruteraan pada 2018 hingga 2021. Beliau telah memberikan pelbagai sumbangan untuk pentadbiran strategi UPM selama bertugas di bahagian perancangan korporat atau singkatannya BPK serta strategi dan komunikasi korporat di mana beliau telah berkhidmat secara langsung di bawah pejabat Naib Chancellor. Beliau telah berkhidmat secara langsung di bawah 4 Naib Chancellor UPM iaitu Tan Sri Nik Datuk Dr. Nik Mustafa Raja Abdullah, Datuk Insinyur Radin Umar Radin Suhadi, Datuk Dr. Muhammad Fauzi Ramlan dan Profesor Datin Paduka Aini Idris. Sewaktu berkhidmat di BPK, beliau memperkenalkan sistem petunjuk prestasi utama Universiti atau KPI pada tahun 2011 yang mengukur pencapaian universiti untuk dilaporkan kepada kementerian. Sistem ini terus diguna pakai sehingga hari ini sebagai alat pemantau prestasi setiap entiti di UPM. Beliau juga bertanggungjawab memperkenalkan sistem peruntukan berasaskan prestasi pada tahun 2011 di mana pengagihan kewangan disalurkan berdasarkan keperluan dan pencapaian setiap fakulti dan institut penyelidikan. Sidang penonton yang dimuliakan, Prof. Kamariah juga secara aktif membantu UPM untuk mencapai pelbagai ranking dan penarafan seperti QS di mana UPM berjaya berada di antara 200 universiti teratas yang disasarkan sejak 2015 ranking setara dan UI Green Metric di mana UPM telah mendapat tempat pertama di Malaysia selama 6 tahun berturut-turut. Beliau juga memainkan peranan penting ketika UPM mengambil langkah untuk mencapai pensijilan ISO pada tahun 1999. Hasilnya, Fakulti Kejuruteraan di bawah Dekan Profesor Insinyur Dr. Radin Omar Radin Suhadi menjadi entiti kedua di UPM setelah Fakulti Perubatan Veterina untuk mendapatkan pensijilan ISO. Beliau juga aktif membantu fakulti lain untuk mencapai status yang sama sehingga seluruh UPM mendapat sijil. Di peringkat kebangsaan, nama beliau amat sinonim dengan Outcome Based Education atau OBE, di mana beliau merupakan pakar rujuk Universiti, Agensi Kelayakan Malaysia atau MQA dan Engineering Accreditation Department. Beliau juga giat dalam sistem penarafan bintang untuk kolej swasta, MyQuest, dari 2010 hingga 2018. Penarafan universiti dan kolej universiti setara 2017, penarafan Institut Pendidikan Guru 2015, penarafan Politeknik di Malaysia, Polyrate dan juga penarafan Kolej Komuniti, MySpec 2016. Beliau juga membantu dalam sektor pendidikan nasional dengan memainkan peranan dalam Pelan Pembangunan Pendidikan Tinggi Malaysia 2015-2025. Menyumbangkan kepakarannya dalam lonjakan 4 yang merupakan bidang pendidikan dan latihan teknikal vocational, TVET. Prof. Kamariah juga terus membantu Kementerian Pengajian Tinggi dalam menyiapkan beberapa playbook, terutamanya buku biru panduan pengurusan prestasi biru. Penonton yang dihormati sekalian, di peringkat antarabangsa, Prof. Kamariah telah berjaya mendapatkan kepercayaan para kolaborator Eropah. Beliau adalah penyelidik utama untuk 3 projek kesatuan Eropah Erasmus yang menyumbang kepada banyak program mobiliti pelajar dan staf dari UPM ke Eropah, terutamanya United Kingdom dan Perancis. Pada tahun 2019, beliau ditugaskan sebagai koordinator negara Malaysia untuk 2 projek Erasmus Plus dan diberi kepercayaan untuk menerajui penyelidikan lebih daripada 1.9 juta euro dari kesatuan Eropah. Prof. Kamariah Noordin juga berperanan sebagai penyelaras program untuk projek Erasmus Plus Malaysian Sustainable Campus Network, MySun, dengan jumlah grant penyelidikan lebih dari 900,000 euro dari Suruhanjaya Eropah pada tahun 2020. Prof. Kamariah juga telah menerima pelbagai pengiktirafan seperti penyelidik terbaik untuk bahagian jurnal dari UPM pada tahun 2016, tesis PhD terbaik dari International Institute of Electrical and Electronic Engineers IEEE USA untuk pelajar di bawah seliaannya, menjadi pengurusi Majlis Dekan Kejuruteraan Malaysia mulai 2018 hingga 2021 dan terdapat pelbagai lagi pencapaian lain. Beliau juga berkhidmat di Jabatan Akreditasi Kejuruteraan Lembaga Jurutera Malaysia sebagai pengarah bersekutu dalam kejuruteraan elektrik sejak 2016. Terkini, beliau juga telah dilantik sebagai Naib Presiden Malaysian Society of Engineering and Technology yang dikenali sebagai MySET. Sekarang, marilah kita mendengar syarahan inaugural oleh Profesor Insinyur Teknologis Dr. Kamariah Noordin yang bertajuk Imagineering Communication, 5G and Beyond. Sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Yang Berbahagia Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor UPM atas ucapan pengenalan tadi. Terima kasih kepada pengacara majlis Dr. Ahmad Salahuddin Muhammad Harizuddin dan juga pembaca doa Encik Salihuddin bin Zainal, keduanya dari Fakulti Kejuruteraan. Terima kasih. Izinkan saya untuk berucap dalam bahasa Inggeris untuk syarahan inaugural saya. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Yang berbahagia Profesor Dr. Muhammad Roslan Sulaiman, Vice Chancellor of Universiti Putra Malaysia. Yang berbahagia Profesor Engineer Dr. Muhammad Khairul Anwar bin Muhammad Arifin, Dean of Faculty of Engineering UPM. Deputy Deans, Heads of Department, my beloved family, my respected mentors, fellow academics, colleagues, industry partners and collaborators, engineering accreditation evaluators, my beloved students and researchers, and all of you who are attending this lecture via Facebook Live streaming today. Assalamualaikum and a very good morning. Today marks the pinnacle of my career in UPM, where I will be delivering my inaugural lecture entitled Imagineering Communication, 5G and Beyond. Many ask me why the title and why do I gaze far and beyond. Well, it is 5G. When 3G allowed us to roam around the world using the same handphone, we thought that is pretty amazing already. But 5G is more than that. 5G allows you to think the unthinkable, to imagine the unimaginable. Who would have thought that we would have the autonomous car driving on its own nowadays? Who would have imagined that all devices can be interconnected with intercommunication, what we now call IoT, remote health, and many more? All these have become a reality thanks to scientists and engineers who never stop to imagine for the better. Even though 5G will only be launched at the end of the year in Malaysia, researchers have already started working on the next generation mobile. Yes, the 6G. It will continue to open up more exploration of research in many areas in the future. So do imagine, and with the help of engineering and technology, all of the unthinkable will become a reality. Hence the title of my lecture today, Imagineering Communication, 5G and Beyond. Let me now share with you the content of my lecture. In the introduction, I will go through with you the evolution of telephone in terms of its looks and its features. We will have a quick overview from the day telephone is introduced to where we are now. Then I will share with you the 3 areas of research in communication that I managed to work with my students and colleagues. They are on diversity and heterogeneity, mobility management, which includes handover and location management, and the 3rd area of focus is green communication. I will conclude with some future direction, in particular, the anticipation of 6th generation mobile. So stay tuned because I have some entertainment for those who stay till the end of this lecture. So let us get started. In the evolution of telephone, I will share with you the brawn, how they look like. Yeah? In 1877, the first Bell telephone looks like that. It looks more like a telescope than a telephone. Yeah? In 1925, we have the rotary phone. Many of you may not have seen it. And we have the first mobile phone in 1960. Yes, it is mobile because it is fixed in automobile. Yeah, and AT&T first picture phone is introduced in 1970. And the first carry phone is introduced in 1980, what we used to call Atur 450, yeah, in Malaysia. From 1983 to 2002, we have this many looks of phone. They are getting slicker and slicker. And in 1996, we have this popular flip phone by Motorola. And many of you may have carried the BlackBerry in the year 2000. And nowadays, from 2006 to 2021, what you are carrying in your pocket and in your purse are this. Yeah? We have Samsung, we have iPhone, we have Huawei, whatever you have. Yeah? So those are the evolution of the telephone on how it looks. Yeah? But before I go further, let me introduce to you the radio spectrum allocation in Malaysia. This is provided by MCMC, or Suruhanjaya Komunikasi and Multimedia Malaysia, in Malay. So we are more interested in the mobile, yeah? The mobile spectrum, the one in yellow, yeah? You see that they pop up from 300 kilohertz to 200 terahertz. They are everywhere, the yellow ones. So those are the spectrum that we are interested in. Okay, if you see the ICT development in 20-year span from 2001 to 2019, you notice that the mobile cellular subscription and also the active mobile broadband subscription are the one that increasing. Yeah? So if you notice per 100 inhabitants for the mobile cellular, there are more than 100 subscription, meaning some of you are having more than 2 lines. Yeah? So, and we also notice the decline in the fixed telephone subscription because many of us don't have fixed phone anymore at home. Yeah, so that is the development of ICT in the 20-year span. That is, I got that from ITU. Yeah, the source is from International Telecommunication Union, published in 2019. Okay, I have shared with you the look. Now let us share with you the brain of the mobile network from 1G, the first generation, to the 5th generation. So in the 1980, when it is first introduced, they are all analog, yeah? And it is only voice with limited coverage and mobility. And the technology that they use is AMS and NMT 450. AMS is used in the US and NMT is mainly in Europe and in Malaysia. Yeah? In 1990, 2G is introduced. It is now digital, improved voice with improved security, improved coverage, and now we have SMS, yeah? Short messaging services, and we have some data. Yeah? The technology that we use is Global Spatial Mobile, which is GSM, and in the US they have IS-95. US always have something different. Yeah? So in between 1990 and 2000, we have this 2.5 generation. It is an enhancement of 2G. The technology is Edge and GPRS. They still are around here. They are still around with us here. Yeah. When I was in Toronto, not far back, yeah, I noticed that I couldn't use my Waze anymore. Yeah, I will usually get lost without my Waze. Yeah. So I noticed that my Waze doesn't work because my 3G fell back to Edge. When I saw my phone, it is Edge. So if you notice, on your phone, it will tell you whether you are on 4G, 3G, Edge, or GPRS. Yeah. So Edge and GPRS do not have that much data to provide me Waze. Yeah. So in 3G, which is introduced in year 2000, we have this mobile data. Yeah. Huge data. Yeah. With higher data rates. And we start having all these smartphones where you can do everything with your phone. You can take pictures, you can do Word, you can do Excel, yeah, with better voice. Yeah, the example of technology that used is wideband CDMA and also CDMA 2000. In between 2000 and 2010, we have this 3.5G or enhancement of 3G, the technology of high-speed downlink packet access. And in 2010, we have this 4th generation, which is totally mobile and totally broadband. Yeah? And it is high-speed data with better smartphones. You can do almost everything, just like a computer. And the technology is long-term evolution or long-term evolution advanced, yeah? And also WiMAX. We are anticipating in 2020, we have this 5G, yeah? So before I go into 5G, let us look at mobile wireless evolution against wireless LAN evolution. From 1G, the mobile wireless evolution start in between 85, yeah, in about 1985. But 1G in wireless LAN start a bit later. So notice that the data rate that they carry is different, yeah. From 1G to 5G, if you notice, the data rate increased from 2.4 kilobits per second to almost 1 gigabits. The anticipation of 5G is about 1 gigabits. But in wireless LAN, you can have more because the coverage is small, yeah? So you have more data. So wireless LAN start at 2 megabits per second in the middle of 1990s, yeah? And it is anticipated to go to close to 7 gigabits per second when 5G is launched. Okay, so that is the evolution. If you notice how everybody is so hungry about data rates, yeah? Okay, so this is the characteristic of 5G, the one that we'll be having soon, yeah, in Malaysia. They are massive machine-type communication with increased capacity of more than 1 million devices per square meter. And they are ultra-reliable and low-latency communications with latency or delay less than 1 millisecond. And it is enhanced mobile broadband with higher data rate of more than 10 gigabits per second. And the characteristic is different because they are catering for different spectrum band. If you notice, they have like 3 bands, yeah, with different data rates. So I will show you. In Malaysia, we have chosen, when I say we, I mean MCMC, has identified The low band for the nationwide is at 700 megahertz. And for metropolitan area, it is 3.5 gigahertz and 26 or 28 gigahertz for the dense urban. This is the millimeter wave, the one that we are really looking for. They are the pioneer spectrum bands for the rollout of 5G in Malaysia. So the 3 cities that has been chosen at the end of the year for this rollout is Kuala Lumpur, Putrajaya, and Cyberjaya. We're really looking forward to this, yeah? And I got this from MCMC, so it better be true. Okay, so this is the 5G in general, the features. It is operating at millimeter wave spectrum, yeah? 26 or 28 gigahertz. And this 5G delivers vastly increased capacity with faster speed and much improved response time, yeah? In comparison to what we have in 3G, the response time or the delay is about 100 milliseconds. And in 4G, it's about 30 milliseconds. But the latency of 5G will be as low as 1 millisecond. This virtually instantaneous response has opened up a whole new world of sophisticated connection application where the world going to look like this, or your town going to look like this. A lot of base station everywhere, yeah, where your hospital is connected to your home, shopping malls is connected to your home is connected to safe vehicles, you know when they're going to arrive, yeah, and even to the farm. So connectivity is everywhere. This is the smart application of 5G that we're talking about. And this is made possible by the technology of Internet of Things, yeah? Big data, Internet of Vehicles, augmented reality, and cloud computing, among others, yeah? Okay, so that opened up a lot of research in 5G or 4G. When I started in 2006, we looked at 4G, yeah, because 4G appeared in 2010. So in 2006, we start working on 4G. And these are the 3 areas of focus that I work on. Yeah, I managed to work with my students and my colleagues. They are diversity and heterogeneity. We also have mobility management that we're going to go through later, and green communication. So let us first go through diversity and heterogeneity. Okay, what is headnets? Yeah, heterogeneous networks is normally called headnets. Yeah, it is a deployment of small cells into picocells, microcells, and femtocells. It is congestion and achieve traffic load offload from mobile devices. They can offload from in between cells. Yeah, so it is a complex network with complex interoperation between the cells, and in some cases when Wi-Fi is there, also the interoperation between the cells and also with the Wi-Fi, especially on the handoff capability. Yeah, so this is the definition of headnets that we're going to look at. Yeah, so headnet is, like I said, it is a combination of many different sizes of cells. Yeah. Okay, so this is a necessary paradigm shift. So you cannot get away from it because millimeter wave envisaged to have the potential of releasing about 30 gigahertz spectrum. Yeah. And what happened in LTE, in the 4G, it is not about spectrum because spectrum is there, but it's more into the infrastructure. The shortage is more on the infrastructure. Yeah. So headnet approach to this is through the deployment of small cells called micro, femto, and pico, like shown in the figure. So in many area or many coverage, you would have different types of size of cells, yeah, and with different base station everywhere. Okay, in headnets, the issues and challenges that we managed to address are 3. The load imbalance, which is due to diverse transmitted powers between micro and pico, and underutilization of the pico base station. Okay, and issue number 2 that we try to address is interference, which happen when offloading UEs for load balancing results in low signal strength and interference, which degrade especially the performance of the UE or user terminal at the end of the cells. Yeah. And the high data rates, the third issue that everybody is trying to address is how do we cater for high data rates? Because how do we maximize the capacity and data rates through the design and deployment of picocells in the 4G system? So those are the study that we try to address. Okay, the issues with offloading, traffic offloading of user equipment or your terminal. So in 4G and 5G, we call it user equipment because it is no longer mobile terminal, it's no longer phone, it can be computer, it can be any devices. So that's why they call it user equipment. Yeah. So offloading this user equipment causes performance degradation in the one, especially at the cell edge due to low signal strength because they are almost at the end of the cells. Yeah? They're far away from the base station. So there's a need to design an efficient load-aware cell association and effective interference mitigation mechanism. Yeah? And the mechanism must be able to balance the load depending on channel gain and access probabilities and should be able to reduce feedback overheads and at the same time maintain the quality of service. So these are the issues that everybody is addressing during the 4G. Yeah. So if you notice, we got some paper that we publish based on this work. Yeah. So those are the issues that we address: the load balancing, and to ensure fairness, we have this solution called hybrid channel gain aware, access aware. So don't worry about the acronym. Yeah? And on the access probability for load balancing, that should consider the targeted QoS. We use this solution called priority aware. Yeah. And on coordination of channel quality and cell load so that the subframe muting ratio interference can be mitigated, we use the channel quality aware and load aware blank subframe muting. So these are the three techniques that we use to address the whole issues of heterogeneity. Okay, based on the signal to interference noise ratio versus the CDF or cumulative density function, the performance of the proposed HCGPA, yeah, we saw that a 3 dB improvement in the cell HUE's signal to interference noise ratio. We have a 3 dB improvement where the interference algorithm that set the muting ratio of the microcell, we set the subframe of the microcell to the number of offloaded picocells so that the performance would not be affected by the number of UEs. Yeah? So this is the results that we have. If you notice, the one that proposed is the one in red or in triangular curve, and another one in the box, yeah, the curve in box. So the first two curve from the top. So that's the one that shows the 3 dB improvement from the current research, from the benchmark work. So that is one result. Another result that I can show with you is the spectral efficiency, which is a function of improvement or degradation of the signal to noise ratio. There's a sharp increase at 50% cumulative density function in the proposed scheme as a result of prioritized access for the HPU. If you notice, the solution that we offer for the second solution, we use the prioritized access for the high priority units. Yeah? And however, the degradation in the spectral efficiency of the low priority units, which is at the cell edge, is in the proposed scheme, is attributed to a decrease in access probability. So we cannot do much about that. Yeah? But we have managed to improve the performance of the high priority units. Okay. We also measure the cell area user equipment throughput and also average user equipment throughput. So we anticipate a less traffic load will have higher average throughput and vice versa. And we also anticipate the fairest cell association scheme will have the least difference in average user equipment throughputs among the many cells and user equipment available. Yeah? The least difference was observed in the proposed technique, thus demonstrate that it has the best throughput fairness performance. Hence, the proposed algorithm exhibit good load balancing fairness and higher spectral efficiency for the HPU. So that is the first work on heterogeneity that we managed to do from 2006 to now. Yeah. And let us continue further. Okay, in headnets also we work on vertical handover. Yeah. Vertical handover happens when mobile nodes move from one coverage area to another with different characteristics. Yeah. Let's look at this scenario. Moving between UMTS, or popularly known as a 3G, to wireless LAN, what happened is during handover, the endpoints of the mobile stream control transmission protocol, or let me call it MSCTP protocol, are required to change the primary link from an old link to new 3G link to the wireless LAN. Yeah? Due to this disparity between the 3G and wireless LAN bandwidth, a packet reordering problem will occur when the mobile node of the MSCTP protocol shifts to a new network, introducing these issues. Yeah? Growing protocol congestion window, fast retransmissions, packet losses, and also reduced efficiency of the receiving MSCTP protocol. So this is the issue in vertical handover in headnets that we're trying to solve. Yeah, and how we do that, we propose a packet reordering model because the issue is in the packet reordering. So we have this model, we call it PRM. To solve this issue in the MAC layer, or MAC media access control layer, we propose the insertion of a packet reordering model inside the mobile node, which will work as a special buffer with a large capacity with one input and one output port to receive the transmission sequence numbers. So after the VHO, all incoming data chunks will be forwarded to the mobile node or the wireless LAN networks. So just by inserting this PRM, this model, this packet reordering model inside the mobile node, we managed to solve the reordering problem in MAC layer. Okay, so the throughput and congestion window of the proposed protocol is shown here. Yeah, it is using this packet reordering model, the average performance throughput increased to 181 kilobits per second, or a 16% increment compared to that of the conventional protocol at 165 kilobits per second. So that is our work on VHO, or vertical handover in headnets. So let me also go through with you a very recent work on resource allocation techniques for downlink orthogonal multiple access, or popularly known as NOMA, which is for 5G wireless system. Yeah. So in this work, the issue is the same. We will require high data rates, higher spectral efficiency, higher energy efficiency. We require low latency. We know there's massive connectivity. So it is difficult for the current OMA, or orthogonal multiple access, used in 4G to overcome these challenges. NOMA, which is the non-orthogonal multiple access, is a promising solution to address these challenges by employing multiple users on the same sub-channel. What happened in OMA? They have one user per channel, per sub-channel. But in NOMA, you can have more than one user. Yeah? So you have more bandwidth, you have more data rates. So it can use the limited frequency, power, and time resources. It can connect massive devices and provide higher data rates. So there are three issues that we address in this study. The user pairing, which is the problem in NOMA, the user pairing and clustering, since NOMA allows multiple users in the same sub-channels. And we have to find an efficient user pairing scheme. The issue number 2 is the allocation of power for each user in the shared sub-channel and across sub-channels. We are to design efficient power allocation schemes. And the third issue is the combination of NOMA headnets, which introduce co-tier and cross-tier interference, as well as fair resource allocation. So we will design a fair resource allocation to solve this problem. So these are the three issues that we are solving, and we managed to measure the sum rate, which is the data rate. The sum rate will give the data rate that we are looking for. If you notice the first curve, our proposed technique is the one in red, and the others are the benchmark work. We anticipate the higher the power at the base station would lead to high power to the users. But if you notice, at 2 watt at the base station, the proposed technique is higher by at least 20% as compared to the benchmark work, or from the current work, or FDMA, is about 50% increase. And for the next measurement on sum rate based on the number of user equipment, if we look at the point for 20 users at the base station, our proposed technique improves the system sum rate by at least 4% against the benchmark works or 20% against the current OFDMA. Okay, so that is one measurement that we do. And another measurement, we also measure energy efficiency, against a base station transmit power, and also system efficiency against number of user terminals. So that's a trade-off between energy efficiency and power consumption. If we look at the curve at 2 watt at the base station, our proposed technique can go up as high as 86% against the current OFDMA. Because we have at least two users in a sub-channels. And in the second results at 20 users with 1 watt power at the base station, the proposed technique improved by at least 60% or 86% against the current OFDMA. So that is the results that we have. And also another results shows that NOMA schemes achieve higher performance than OFDMA scheme because more than one user can be assigned in single sub-channel. And the energy efficiency using proposed NOMA is notably high due to efficient assignment of the additional transmitted power compared to the benchmark methods. We publish in Q1 IEEE Access, if you care. So that is the solution that we come up with this study. Okay, so the next area of focus is on mobility management. We started working on this from 2015 up to now. And let me share one study that we do with you. But before that, let me define what is mobility management. Mobility management would include handover management and also location management. So handover is responsible for maintaining the user's connection as the user or mobile terminal roams and switch its access point to the network. When mobile terminal is in headnet, handover management also has to promise the best connectivity to the mobile terminal through connection with the best available networks. They will find the best network for them to be connected. At the same time, location management also have to happen. So handover management and location management has to work hand in hand because in location management, it allows the backend network to track the mobile terminal's attachment where they are, the attachment point between consecutive communication. So that is, in general, what mobility management is. So in this study, if you look at the current scenario, the current mobility management is based on centralized mobility management protocols. It increased the increase of ubiquitous devices and cellular demands for telcos to look for a scalable and reliable mobility solution in headnets, coupled with the current IP mobility management solution, which are in hierarchical manner, which are centralized, which is the main problem of mobility management currently. So what we propose in this study, but before that, let me go into what is the problem with centralized mobility management? What are the issues involved in CMM? So number one, all data traffic has to pass through the central anchor point that lead to increase of end-to-end delay. So there's only one central point. So everybody got to go through that. And issue number two, it made worse with the growing number of mobile users that demand for data bandwidth, coupled with the requirement to maintain mobility context, to maintain at the base station where they are supposed to be connected. And issue number three, the centralized mobility management architecture with single centralized anchor is prone to single point of failure and attack. One that is attacked, they're gone. So we are all performance is lost. And issue number four is the current CMM lacks granularity on mobility support functions such that unnecessary mobility support are provided to the users that do not require the mobility support. So there is a loss there because they introduce overheads. So those are the four issues that our study tried to focus. So this study, because we know that in CMM, it has this one central mobility anchor, and it's also it has this the architecture is centralized. So this study focused on the design of a network-based, fully distributed mobility management, FDMM, fully distributed scheme for headnets in 5G through modification of the current CMM solutions. And if you notice from the figure, dedicated mobility anchors such as the local mobility anchor in the current centralized mobility management approach and the centralized mobility data in the partially distributed MM approach were removed from the core network in the proposed scheme. We totally removed the central mobility database and now everything is distributed. Yeah. So based on this architecture, we come up with FDMM schemes and its relationship, and we also compare the simulation and analytical model of that architecture, and this is the summary of the results. If you notice, the very bottom is actually our solution, where the signaling costs, data costs are all low as compared to the benchmark work. And we did not cater for QoS, however, but the complexity is low. So I can summarize the result for you. The distributed mobility management that we propose shows 80% lower data costs when compared to CMM, and we do this analytically. We don't do it through simulation. So, and summary number 2, the distributed mobility management has 37 reduction in the end-to-end delay compared to centralized mobility management done in the simulation. And the third summary is the DMM, or distributed mobility management with distributed authentication, reduced packet loss by 54%. That's a lot, And finally, our proposed logic interface-based, fully distributed mobility management has low complexity compared to media independent-based FDMM. So those are significant results that I can summarize from the study. Okay, let me go to the third and the last area of focus that I managed to share with you today, which is green communication. We started working on this from 2016 to now. Okay, what is the current scenario in green communication? We know there's a lot of smart application, network and technological expansions, and the growth of ICT. We saw the figure right in the beginning, how ICT has developed, how they have increased so much. And also, 4G networks are approaching maturity. That's why we are introducing 5G. And installation of 5G network around the world to provide 1,000 times more capacity to serve massive number of devices. So that introduced the rise in transmit power. So what do we do with that? So let's look to some data. The projected carbon footprint, which is published by Hefske et al. In 2011. He anticipated already in 2011 that this is the carbon footprint contributed by mobile devices, contributed to the manufacturing, to the operation, to the radio access network operation, and many more. And the 5 categories of power consumption of a typical cellular network, published by Han et al. In 2011 also, show that the bulk of the power used is at the base station. More than 60% is at the base station. So what do we do with that? And the rest are at mobile switching, core transmission, data center, and the rest. Okay, let's see again why green communication is introduced. Because of increase in devices number, up to 100 billion by 2020, coupled with corresponding rise in the energy, which means higher OPEX for the telcos. And the amount of carbon emission from the cellular network is predicted to be 345 million tons, contributing to 2% of total emission increase. So the increase is 2%, even though it's small, it is huge actually. So that is why the need to address green communication, addressing the efficiency of power consumption and also focusing on the sustainability of telecommunication from other aspects. User healthcare, extended lifespan of devices, and efficient resource allocation. Okay, so that is why we need green communication. So this is a study that we done in 2016 actually. So the current spectrum allocation process in the downlink, downlink meaning from the base station to your user terminal, is based on the user channel status on specific resource block. Yeah? To maximize the downlink performance, the base station, or what we normally call E node B, yeah? So I'm going to call base station because many of you are not in telecommunication, should have perfect channel state. So to maximize this performance, the base station should have perfect channel state information. Yeah? So each user must report its CQI or channel state indicator, but with huge number of users, it is not feasible for all users to report the CQI for all resource block. So this full band CQI feedback scheme is not spectrum efficient nor energy efficient due to the high signaling or overhead produced. Hence, there's a need to optimize the spectrum and energy efficiency, which contributing to green communication, through transmission power reduction without neglecting the data rate and QoS requirement. So this is the issue that we're trying to solve. And the methodology that we use is we break this problem into 3 stages. Yeah? First, we look at the energy efficient scheduler, yeah, with CQI multi-criteria selection. And in stage 2, we look at how we can adapt the threshold of the CQI through partial feedback scheme for LTE system. So this is done for LTE system specifically. Yeah? So later, we combine these 2 techniques and we call it self-configured link adaptation with partial feedback to produce a total solution to reduce the energy. Yeah? Okay, so this is the first stage of the block diagram of the proposed CQI multi-criteria selection mapping. And we published in Transaction of Emerging Telecommunication that was in 2014. Yeah? Okay, so the results of the first stage on energy efficiency against user equipment numbers per cell. And if you look at the figure B, that is spectral efficiency against user equipment number per cell and also carbon emission. So from the perspective of energy efficiency, spectral efficiency, and carbon emission, it is seen that the proposed method show the most promising results. So the one that we should look for is the one in green. Yeah? So not only can it uphold the energy efficiency and spectral efficiency, but the carbon emission was also reduced. Okay, so that is the first stage results that I can share with you. This is the second stage of the block diagram. Yeah, we also publish in some journal. Yeah, and in this results for stage 2, we measure the throughput, yeah, against user equipment number per cells. And we also measure packet loss ratio against user equipment number per cells and overheads induced against user equipment number per cells. So the proposed technique can determine the trade-off, yeah, between the feedback overhead and corresponding downlink parameters, achieving better overall performance than the wideband feedback scheme, yeah, the current wideband feedback scheme. It is also high flexibility in adapting its performance according to various preference and condition, because we have that multi-criteria selection mapping that we put in the first stage. Okay, for the total solution, the deployment of both the link and adaptation and partial feedback algorithm in the self-configured link adaptation algorithm at the base station allows the base station to configure the priority weightage of the competing criteria according to the targeted quality of service. So this combined method has to be implemented at both the transmitting and receiving ends simultaneously to jointly optimize the system performance. So that is one work that we contributed on green communication. Yeah. So we also measure results comparison on packet loss rate against user equipment number per cell, and also spectral efficiency against user number per cell, and the overall performance gain as shown in the figure. Okay. So let me conclude with some future direction. Yeah. So I was looking at 4G and 5G earlier on, but everybody start going for 6G already. This is the paper published in 2019 by my Mahaguru, yeah, Theodore Rappaport. Yeah, I used his book for like more than 20 years. Yeah, so he is a fellow in IEEE. Yeah, and he already published this. This is invited paper. Not many people get invited to publish in this Q1 journal. Yeah, so they have started working on 6G in 2019. Yeah. So what do we anticipate 6G going to do? Yeah. Technical requirement. If you look at the red, that is 5G features, and the 6G is the one in blue. You notice how different they are. Yeah. I mentioned earlier, 5G can only give us 1 millisecond latency. The delay is 1 millisecond, but we are talking about 0.1 in 6G. Yeah, 0.1 millisecond. It's like nothing. It's like instantaneous. It's like you can even blink your eye. Yeah, and the reliability is like almost 100%, and you can go as fast as 1,000 kilometer an hour. So I don't know. That is like a supersonic. Yeah. And the user experience rate is 1 gigabit, yeah, the anticipation. But the accuracy, if we go into Google Map, we thought it is good already. If we found it's like about 65 meter accuracy, yeah. But we are talking about position accuracy of 0.01 meter, yeah. It's about just next to you, yeah. Okay, so that is the anticipation of 6G, and this is how they're going to look like. The world is a mess. Yeah, so that is the conclusion that I'm trying to derive. Yeah, so everybody is interconnected to everything. So you're not just interconnected with your buddies, but also to everything in the house. Probably you can talk to your refrigerator. Yeah, to your. But now you can talk to your TV already, so that is more now. Yeah, that will be more in 6G. Okay, so that is what I'm trying to arrive at. Yeah, as the conclusion. I also like to share with you this special dedication. I would like to dedicate this inaugural lecture to my beloved parents, Allahyarham Haji Noordin Yaakob and Allahyarhumah Isa Muhammad. May Allah be pleased with them and shower His blessings upon their souls and place them among the righteous. Amin. And also want to show my gratitude and thank you to my husband, Engineer Ahmad Zaini Abdul Karim, mentors, Allahyarham Professor Datuk Engineer Radin Umar Radin Sohadi, Datin Paduka Setia Aini Idris, Datuk Muhammad Saleh Jaafar, and Prof Burhanuddin Muhammad Ali. And to my children, Dr. Nadia Husaini, Hilal Husaini, Hafiz Husaini, Aiman Hakimi, Atika, Aminur Rashid, Amirul Anwar, and Ahmad Yusri. And my special gratitude goes to Dr. Liu Junteng for assisting me with the writing of the book, and Datin Dr. Mazia Hayati Abdullah for perfecting the narrative of NK Life. Thank you so much. And I also like to say thank you to the Department of Computer and Communication System Engineering. They are all there, yeah? And they're all here. I'm sorry if I miss your name, but we have checked. They're all here. Yeah, and thanks to all my students. Yeah, I couldn't capture all your pictures, but most of you are here. And they are here actually, the one that I supervise and the one that I co-supervise. Yeah. And my appreciation to all my personal assistants and administrators who have eased my administrative work during the 20-year span of my career. They are all here, inshallah. Yeah. Ladies and gentlemen, I'm privileged to share with you the ups and downs of my life during these 5 decades through this video presentation. Thank you so much, and thank you for listening to my inaugural lecture.
Majlis merakamkan ucapan terima kasih di atas penyampaian syarahan inaugural oleh Yang Berbahagia Profesor Engineer Teknologis Dr. Kamariah Noordin. Sidang penonton yang dihormati sekalian, dengan ini maka berakhirlah sudah syarahan inaugural pada pagi ini. Sekali lagi majlis merakamkan ucapan terima kasih di atas kesudian anda semua yang mengikuti secara dalam talian. Terima kasih dan stay safe.